All right, let's jump right in. We're going to be talking about one of the coolest frontiers in architecture today, buildings that aren't just, well, buildings. We're talking about dynamic, living structures that can actually react, adapt, and even breathe. It's some seriously next-level stuff, so let's get into it.
So, first things first, we've got to talk about why this matters so much. And honestly, the stakes could not be higher. This quote right here, it sets the stage for everything we're about to discuss. Think about it. Buildings, the very things we design to shelter us, are the single biggest source of carbon emissions. That's a huge problem, and it's our problem to solve.
So, that leads to a really powerful question. What if our buildings could actually fight back? I mean, what if they could stop being these massive energy hogs and start being part of the solution? That's the big idea we're diving into. Section 1. The static building problem. Forever, buildings have basically been static shells, right? Just fixed walls against the wind and rain. But now, we're chasing these really ambitious goals, like nearly zero energy buildings, or NZEBs as you'll hear them called. And for that, the old way of just building a passive solid box, it's just not going to cut it anymore. And that's where active systems come into play. Now, don't get me wrong, good passive design is always your starting point. You know, things like getting the building's orientation right, using thermal mass, natural ventilation, all that good stuff. But eventually, those passive strategies hit a wall. That's when active systems need to take over. Basically, these are devices that use energy, electricity usually, to control things like temperature and air quality. You can almost think of them as the building's muscles and nervous system, making things happen on command.
This image just says it all, doesn't it? It's the perfect way to see the huge leap in thinking we're talking about. On the left, you've got your typical static glass box. And on the right, the Al-Bahar Towers, a building that literally changes its shape all day long. We are moving away from the idea of a fixed wall and towards this concept of a responsive, living skin.
Section 2. Introducing the alive skin. And that idea, that metaphor of an alive skin, is just so perfect. As architects, it forces us to rethink what a facade even is. It's not just a barrier anymore. It's this smart, adaptable membrane between the interior and the exterior world.
So, how exactly does a building's skin move? Well, it usually breaks down into 4 main types of movement. You've got parts that can rotate, parts that fold up, parts that slide or move across, and even parts that can scale, get bigger or smaller. This is pretty much the basic toolkit you have to play with when you're designing kinetic architecture.
Okay, part 3, kinetic facades in motion. Let's get to the good stuff. We're going to look at how these ideas actually play out in some truly incredible real-world buildings. These are structures that physically change their shape to deal with sun and heat. It's amazing.
First up, we're headed to Austria to check out the Kiefer Technic Showroom. And just look at it. The way it looks is constantly changing. It's really more than just a building. It's like watching a piece of performance art, a totally choreographed dance of metal panels, light, and shadow.
So let's peek behind the curtain and see how this magic actually works. The whole facade is made of 112 perforated aluminum tiles, and they're moved by 56 little electric engines. But the real genius here is the material choice. That aluminum has a high albedo, which is just a fancy way of saying it's really reflective. It bounces back 60 to 80% of the sun's heat. And because the panels are perforated, you still get this beautiful diffused daylight inside, and you can still see out.
And here you can see it up close. The whole system is automated. It literally tracks the sun across the sky to give the perfect amount of shade at any given moment. But, and this is super important, it also has a manual override, so the people inside can adjust it themselves, giving them total control over their own space. Okay, so we're leaving the relatively mild weather of Austria and heading somewhere much more extreme, the desert heat of Abu Dhabi. This is the Al-Bahar Towers. And you can imagine the challenge here is on a whole different level. Their solution is just brilliant because it's super high-tech but also deeply inspired by local culture. What you're seeing is basically a 21st century version of the mashrabiyah, which is a traditional Islamic screen used for shade and privacy. The facade has over 2,000 of these individual umbrella-like shades. They're made from a tough, stretched fabric called PTFE, think Teflon, and they progressively open and close as the sun moves. It creates this incredible, ever-changing shield that literally follows the sun to block out that intense heat. Okay, Section 4. Facades of smart matter. So everything we've looked at so far involves big, mechanical parts moving around. But what if the building could adapt without any moving parts at all?
What if the change happened right inside the material itself? This is where we get into the really futuristic world of smart matter. And there are basically two big players in this field. First, you have chromogenic glass. You zap it with a little bit of electricity and it tints itself, kind of like transition sunglasses for a building. It blocks heat, but you can still see through it. Then you have something totally different. ETFE cushions. These are basically inflatable pillows that you can change by adjusting the air pressure inside.
And if you want to see ETFE in action, you have to look at the MediaTek building in Barcelona. This place is an absolute icon for this kind of tech. I mean, yeah, kind of looks like it's wrapped in giant bubble wrap, but what's really happening is that this building is, well, it's breathing.
So why would you use this stuff instead of glass? The numbers are pretty mind-blowing. ETFE weighs only 1% of what the same size piece of glass would weigh. Just think about how much that saves you on the steel structure underneath. Oh, and it's also 100% recyclable. It's a huge win for sustainability. And the environmental impact? It's huge. By intelligently managing the sun's heat, that ETFE facade stops about 114 tons of CO2 from being pumped into the atmosphere every single year. All because it slashes the need for air conditioning. But here's the absolute coolest part. On the side of the building that gets blasted by the sun, they can actually pump a nitrogen-based fog into the ETFE cushions. It basically creates a man-made cloud right inside the wall, acting as this incredible insulation barrier against the heat. It's a building that literally makes its own weather. How cool is that? Section 5. The Architect's Dilemma. Okay, so all of this tech is obviously incredible. But, and this is a big but, with big innovation comes big risk. And this leads us to a really important lesson, a kind of dilemma that every single architect who wants to work with this stuff has to think about. For this, we need to go back in time a bit, to 1987. We're in Paris, looking at Jean Nouvel's masterpiece, the Institut du Monde Arabe. This building was a true pioneer. Its south facade is just breathtaking. It's a wall made of thousands of tiny, photosensitive diaphragms, like the apertures on a camera lens. And they were designed to open and close automatically with the changing sunlight. It was brilliant, it was beautiful, and it failed. This is the ultimate cautionary tale. Just imagine trying to maintain thousands upon thousands of tiny, moving parts and servo motors. It was a maintenance nightmare. Things were constantly breaking, and in the end, they just gave up. The whole kinetic system was abandoned. And the tragic irony is that today, this landmark of responsive design is cooled with good old-fashioned air conditioning, the exact thing its amazing facade was meant to replace. And that leaves us, and more importantly you, the next generation of architects, with a really fundamental question. Innovation is the easy part, right? Anyone can design a wild, complex system and software. But reliability, that's the hard part. Making something that will actually work, day in and day out, for the 50 or 100-year life of a building. So as you move forward, you have to constantly ask yourself, what's the right balance between those two? What will you choose to build?